How does thermodynamic equilibrium relate to temperature? Have you ever wondered how two objects can be at the same temperature? This question leads us to the fascinating world of thermodynamic equilibrium and its connection to temperature. Let's break it down in a simple way. Thermodynamic equilibrium, especially thermal equilibrium, is all about energy balance. When two systems are in contact and can exchange energy, they will eventually reach a point where no energy flows between them. This is when they are said to be in thermal equilibrium. At this stage, their temperatures are equal. The Zeroth law of thermodynamics is the principle that helps us understand this concept. It states that if system A is in thermal equilibrium with system B, and system B is in thermal equilibrium with system C, then system A must also be in thermal equilibrium with system C. This law is essential because it allows us to use temperature as a reliable measure to determine if systems are in thermal equilibrium. Think about a thermometer. When you place it in a liquid, it measures the temperature of that liquid. If the thermometer and the liquid do not exchange energy, they are at the same temperature. This is thermal equilibrium in action. Now, let's talk about temperature itself. Temperature measures the average kinetic energy of particles in a system. When two systems with different temperatures come into contact, energy flows from the hotter system to the cooler one. This continues until both systems reach the same temperature, establishing thermal equilibrium. In practical terms, understanding thermodynamic equilibrium and temperature has many applications. For instance, when using thermometers, designing thermal insulation, or even in engines and refrigerators, this knowledge helps us understand how energy balances out. So, thermodynamic equilibrium relates to temperature by defining a state where two or more systems have the same temperature and no net heat flow occurs. This equality of temperature is what characterizes thermodynamic equilibrium in terms of heat exchange. By grasping these concepts, we can better appreciate how heat flows and how systems stabilize over time. Understanding thermal equilibrium is key to many everyday processes and technologies we encounter.